Hello, welcome to the final presentation for the network science course. And this project is done by me, Kathiravan Jayapalan, for the master's um, data science course. So this project is about the analysis of provider networks. So provider network in the sense, it's about the healthcare claims data. So healthcare claims data will have provider, members, and the service offered between them. So I'm going to analyze the network model of the claims data, the healthcare claims data set here. So why network model for this provider member data, right? So healthcare claims data mainly consists of providers, members, and the services which interconnects them. So when you take a claim data, healthcare claim data, it will be raised by a provider. So it will have the provider ID and the member who got the service from the provider, and then the service details and the amount charged by the provider and so on. So the intention of providing the best healthcare experience to all the plan members urges the healthcare insurance company to investigate the network topology of the providers, patient flow between them, or physician centralities, to provide a best healthcare experience to all the plan members. So this is a typical network model that I arrived at when I worked on the claims data. So I'll be showing how this kind of model is arrived. So the project overview. So what I did here is, since healthcare data is the most sensitive data, right? So it has members' personal information or what are the services offered by the provider to the member and all. So, um, so we are not going to look at real data here, but Kaggle had a data set, claims data set with dummy provider IDs and member IDs. And in that Kaggle data set, they used the data set for predicting the fraudulent providers. So I'm going to take advantage of that data set and show a network model for that healthcare claims data set. So basically, I took the flat claims data, inpatient, outpatient claims data from that Kaggle data set. And then I took the member IDs, provider IDs, and the claim details. So it was a tabular data. It's a comma separated file. So I created a Python program to convert this tabular data into a GML file, into a GML file format. And then I used the networks library to load the GML file into networks graph, and then set various attributes like centralities, link community detection attributes and all. And then after setting all these attributes on the networks graph, then I generated a GEXO file. So basically it's a GML file along with the attributes, and then generated this file and then loaded this file into Gephi. So once this GEXF file is loaded into Gephi, I was able to see the nodes, that means the providers and members, and the edges, which are nothing but the claims raised between the provider and member as an undirected graph, because a member can choose a provider and at the same time a provider can refer another provider also. So I loaded it as an undirected graph and then analyzed the network with the tools available in Gephi. So what I'm going to do with this project is, once I analyzed the network model of the healthcare claims, I tried to report the findings and validate if this network approach for the healthcare claims data really helped with solving the original Kaggle problem, which is identifying fraudulent providers. So before going into the project, let me discuss a brief summary on the existing work on provider models. So this one is about an attempt to understand the physician network dynamics to bring down the healthcare cost. So this work shows that there is an average cost reduction in healthcare expenses when the centrality between the providers or physicians increase. So basically, more physicians in a network, less uh, um, cost in healthcare. So that's what this work talks about. So, however, this model considers only the provider in the network and not the members. So another work I read about before doing this project is this one. So where in this paper, the topology of the healthcare networks constructed from claims data is shown that it will vary as a function of the algorithms which are used to construct them. So this work emphasizes on the choice of network construction algorithm, which is critical for healthcare network analysis. So again, in this work also, only providers are considered as nodes and not the members. So then I had one more work to review. So it's a rigorous modeling and a meaningful analysis of the mass of claims data produced by healthcare network. So this work was useful to inform healthcare managers about the status of the service under their responsibility and the degree of collaboration which happens between the entities of the network. So entities in the sense the provider, members, physicians, and so on. So this model considers both providers. Of course, it considers all the entities here as a network model. But in this project, we are going to take only providers and members and nodes and the claims as edges and analyze the network model between them. So the research started with creating a network model of the healthcare claims data and analyze it using the graph in networks and Gephi. So that was the start of the investigation in this project. So the expectation was to identify interesting features from the graph, which was created using the claims data, interesting features between providers and members. And the work planned on the expected features from the graph is to analyze the network topology between the providers and members, what kind of network model we are going to get when we put the provider and member data into a network model, and to analyze the patient referral patterns, like how providers are referring the patients to another providers and how we can identify them, and also to identify provider communities. So my expectation is that if I succeed in identifying provider communities through claims data, then it would help me to identify fraudulent providers also. So that is the reason I try to find provider communities here, and also to identify physician centralities. So based on the work, one of the existing work, we found that more physician centralities gives us less cost in healthcare expenses. So I'm trying to identify with the existing tools if there is physician centralities also. And finally, after analyzing all these features, I'm going to see if these features are going to help me to identify provider frauds and compare those providers with the fraudulent providers identified by the original Kaggle machine learning algorithm, and see if the network model, helps or not. So the input data considered for this project is, as I told, it's a Kaggle data, which was initially used for predicting provider fraud detection. So the same data set has been used here. So basically, it's a claims data. It's a tabular data between provider and member. And also there is one more data set for the final, which is the final output of the Kaggle machine learning algorithm. It will have the list of provider IDs, and it will have whether he's a fraud, whether he did fraudulent activities or not, yes or no. So that list I used to compare the results of the network model. So these are the two main data set used in this project. So to start with the project, so it involved a pre-processing of the data, because what we received from the Kaggle dataset is a flat file, claims file. So first I have to take the claims and provider details from the flat file, and I put it in a comma separated file. And even though the networks offers method called read underscore adj list to load a flat file directly into a graph, so I found that it was not performing well for more than 3K of data. So since I have more claims, I had to create a Python program to convert this data, provider member data, into a GML file format. And then, so once the GML file is created, I loaded the GML file into networks, and then created a graph, and then set variable attributes to the graph, like centralities, betweenness centralities, closeness centralities, link communication detection, all those attributes I found and then set to the graph. After setting the attributes, then I generated the GEXF file to be loaded into Gephi for further analysis. So the network analysis done on the final GEXF file is this. So basically, analyzed the star network topology between providers and networks and members. So because more members tend to have few providers, so basically I ended up in a star topology model between providers and members. And between a centrality found to be identifying patient referral patterns. So I'll show you in a while like how it worked. And then the network model also identified provider communities using modularity. So basically I assigned the modularity attribute to the nodes and ranked the nodes accordingly to see provider communities, and also linked detection based on the link-com attribute. And also physician centrality found to be mapped to the closeness centrality of the providers. So the more closeness centrality the provider has, the more physician centrality the model ended up with. And also I finally analyzed if all these features are helping to identifying for fraudulent providers. So these are the steps used in this project. Basically pre-process and create a GML file, and then loaded the GML file into the networks graph, then set up attributes, various centralities and link-com attributes, and then generate the GEXF file, and then finally load the GEXF file into Gephi and analyze the network. So this is the network model which I have arrived with based on the healthcare claims data. So you can see the providers and provider nodes are in the center of the star model, and the members are around the providers. So basically each edge is one claim, so between the provider and the member. So you can see a lot of star topology between providers and members here. So here the nodes are ranked based on the degree. So that is the reason you see provider with more in degree are showing bigger here. So what are the results in this model which I have created as part of the project? So basically, the investigation result is healthcare claims mostly follow a star network model because more members tend to have less providers between them. Centralities can be used for predicting provider frauds, cost savings, and referral pattern identification. Yes, so basically provider frauds, cost savings, that is physician centralities, and referral patterns are able to be identified using centralities. I'm going to show you in a while. And in this project, I have used the Fruchterman, Reingold, and OpenORD layouts throughout this project. So those two layouts are found to be, fitting well for this data. So I used these two layouts throughout this project. And the results derived from this model, basically modularity and the link community detection produced similar results of the fraudulent providers predicted by machine learning algorithms. So basically, provider with more modularity or provider with more link community found to be having a possibility of fraud as per the machine learning algorithm. So consider this Gephi output, which I arrived for this data. So basically, from this network, the providers and members are following a star network model. So you can see a lot of stars between providers and networks. And each of these stars are also having a weak tie with the other networks because one member can go to more than 2 providers, or a provider can refer a member to other providers as well. The next one is the betweenness centralities, showing the provider referral patterns. So I have zoomed this network model here. So here you can see the provider 52009 is referring the member 11670 to another provider 52123. So the more the provider has betweenness centrality, the more the provider is referring member to another providers. So another result is the provider communities. So the first picture is the provider communities using modularity. So basically the nodes are a partition based on the modularity here. And the second picture is the edges are mapped to the link community detection, LinkCom attribute. So basically the provider communities are clearly visible here. So the middle one is a provider and all the other nodes are the members getting services from the provider. So basically all these providers having communities are more prone to committing frauds. So the physician centrality shown by closeness centrality here. So closeness centrality is revealing how close or how more number of providers are present for the members in the network. You can see this example provider 52019 having more closeness centrality and having lot of claims for the members around him. So I have here, I have zoomed the modularity provider community based on modularity and the provider community based on link detection community. So here we can clearly see the providers having big communities. So what I did is I took all these provider IDs having big communities and then verified with the fraudulent providers predicted by the machine learning algorithms. They have a 90% match. So basically, providers having unusually big communities are possibly having fraudulent claims. So we cannot exactly say that all the providers having big communities are have committed frauds, but this is a beginner step. So we can take all these provider IDs from this network model and then proceed to further analysis, like how much amount is involved in this activity, how many claims are involved, or what are the services involved. Are those really critical services, or repetitive services which are not even necessary for the particular member and all. So this step can be used as an initial pre-processing step in the prediction of fraudulent providers, and the network models do helps us in predicting the fraudulent claims based on modularity provider communities and link detection provider communities. Coming to the challenges faced in this project, so basically the tabular data file are not able to be loaded directly into networks because it is not performing well for more claims. So I had to create my own Python program for that. And also Jeffy was not performing well for claims more than 10,000. So I have to reduce my data input to 3,000 claims and then work on the project, and that was decently performing. Since both providers and members were nodes in this model, so it's difficult to identify whether the centralities are depends on the provider or members. So I had to depend on the labels for this. So I basically ranked the nodes based on some attribute and then made the label to look bigger and then identified whether it is provider or member. And future works for this project, so similar to this work, removing the members, we can just have a provider network alone. Instead of using claim data, we can use referral or authorization data, which will have the referrals data between providers, and then we can analyze how the referral pattern works, and um, whether the referral pattern is really needed or not, or it is a fraudulent pattern or something. Another model between can be developed between members and their drug choice also, like whether the drugs which are used by the members are really needed, or it is a kind of waste and abuse by the plan members. So that can be implemented using the same network model. And also this work can be extended to identify more centrality measures and communities, which could lead to the detection of new scopes in healthcare models, and which would really help in reducing cost and improve healthcare experience. So these are the works cited for this project. um, thank thank you for opportunity for in this course to work on data and learn more about network analysis. Thank you, Professor.